Okay, today we are going to talk about the limiting reactant and how to find it given information in a problem. As I told you guys the other day, limiting reactant is kind of like you're baking a cake. And let's say there are 3 ingredients for the cake. You've got flour, water, and eggs. And you got a ton of water because it's coming out of the tap. You got a ton of flour. You got 5 bags of it in your garage. And you look in the fridge, you only got a dozen eggs. So you can only make as much cake as the dozen eggs will let you. Once those dozen eggs are gone, then you can't make any more cake. So the eggs are your limiting reactant, okay? And a chemical reaction works the same way. We're going to look at the following combustion reaction. We have 2C2H2 plus 5O2 yields 2H2O plus 4 CO2. And in this problem, let's say that you're given that you have 50 grams of O2 and 25 grams of C2H2. Our first problem here is going to be to find the limiting reactant. And at first glance, you're going to say, oh, it's got to be the C2H2 because there's less C2H2 than there is O2. Except when you look at the molar ratio in the problem above, you only need 2 moles of C2H2, but you need 5 moles of O2. So just looking at the masses alone is not going to give you enough information to find out which one is the limiting reactant and which one is the excess reactant. You need to actually do some stoichiometry. So here's one method for finding the limiting reactant. Take both amounts of the reactant given and do a stoichiometry problem to find out how much of a product is produced. So let's go ahead and pick H2O as the product that we are concerned with. So first we're going to start with 50 grams of O2. So let's figure out, with 50 grams of O2, how much water will we produce? Okay? We're doing a standard stoichiometry problem just like we've done all along. So we convert it into moles, and O2 is 32 grams for 1 mole. Got it right this time. And moving along, we now have moles. We can do the molar ratio. And on the bottom, we have 5 moles of O2 is to 2 moles of H2O. And we want a mass here because that's going to actually be the best in the long run and provide us a little bit of a shortcut. So we have moles of H2O. So 1 mole of H2O is, let's see, 2 plus 16, that's 18 grams of H2O. So double checking, moles of H2O on top and bottom cancel, moles of O2 on top and bottom cancel, grams of O2 on top and bottom cancel. We do the math, multiplying everything across and dividing, and we end up with 11.25 grams of H2O. Okay, that's how much H2O I could produce with 50 grams of oxygen and an excess of C2H2. Okay, now let's see how much I would produce with 25 grams of C2H2 and an excess of O2. So let's do another stoichiometry problem, now doing the 25 grams of C2H2. Converting into moles, let's see, we have 24 plus 2, that's 26 grams of C2H2 is 1 mole of C2H2. Doing the molar ratio, we have, let's see, it's 2 moles of C2H2, and that comes from the balanced equation above, is equivalent to 2 moles of H2O. So it's a 1-to-1 molar ratio, and you could have used that if you wanted to. And now let's get a mass of H2O. So 1 mole of H2O is 18 grams of H2O. Here we do the math, multiplying across and dividing, and we end up with 17.3 grams of H2O. Now, here's the trick to the method. If I've got 50 grams of O2, I could produce a maximum of 11.25 grams of H2O. If I start with 25 grams of C2H2, I can produce 17.3 grams of H2O. The limiting reactant is the one that will produce less. So our limiting reactant in this case is the O2 because it produces the least amount of the product. All right? So limiting reactant, O2. The excess reactant is the C2H2. Okay, so from the previous screen, we have this. Oh, I need to get the pen back. We have this. The O2 is limiting, and the C2H2 is excess. All right? And that's important because we would have thought that with more, 50 grams of O2, that would have been the excess, but that's not actually the case. Okay? So now we get to the second part of the question. Yeah, we're not done. It's a long one. And the second part of the question would be how much H2O is produced. Well, because of the way that we did this problem, this is actually a really easy question to answer. Because all I've got to do is go back and look at the stoichiometry that I just did, starting with the O2, because we always start our stoichiometry with the limiting reactant, and we find out already that we've calculated the amount of H2O that would be produced. And from the previous screen, it was 11.25 grams of H2O is produced. We don't use the 17.3 grams that we got from the C2H2 because that's the excess reactant. We always, always, always use the limiting reactant for our stoichiometry. Okay, that's very, very important. All right. The next part of this question we could ask would be how much CO2 in liters, because it's a gas, so we're going to do a volume one, is produced. So this is just a straight up stoichiometry problem, and as we said already, we always use the limiting reactant, so we start with our 50 grams of O2. And we quickly go, let's see, the molar mass of O2 is 32 grams, and that's 1 mole. Grams of O2 on top and bottom cancel. We use the molar ratio. This time, be careful for O2 and CO2. So it's 5 moles of O2 here, and it's only 4 moles of CO2. And again, that's given from the coefficients in the balanced equation above. So moles of O2 on top and bottom cancel. And last, we want a volume this time for CO2. So 1 mole of CO2 is the magic number, 22.4 liters of CO2. And doing the math, multiplying across and dividing, we end up with a nice round number of 28.0 liters of CO2 produced. Now we get to the third question that we can ask based on the limiting reactant. And that is how much, let's try that again, much C2H2 H2 goes unreacted. And remembering that we had 25 grams of C2H2 at the start and 50 grams of O2. And the 50 grams of O2 ended up being our limiting reactant. So we are asking ourselves how much of this, which is the excess reactant, is left. Okay, remember we started with 25 grams of C2H2. Okay, a certain amount of that is going to react with that 50 grams of O2, but not all of it. Once the O2 is gone, the reaction stops and you're going to have some leftover C2H2. So we need to figure out how much is left over. To do that, again, it's a straight up stoichiometry problem. And we remember that we always start with the limiting reactant. So again, 50 grams of O2. So how much C2H2 would react with the 50 grams of O2? First, we convert it into moles. So 32 grams of O2 is 1 mole of O2. Now we compare that to the C2H2. So we need that molar ratio, and it's 5 to 2. Okay, so 5 moles of O2 is equivalent to 2 moles of C2H2. Now we want a mass because we were given our C2H2 initially in mass. So let's go ahead and say 1 mole of C2H2, which again is 24 plus 2, so that's 26 grams of C2H2. Double check here, moles of C2H2 on top and bottom cancel, moles of O2 on top and bottom cancel, grams of O2 on top and bottom cancel, and we're left with grams of C2H2. So we do our math across and divide, and we get 16.25 grams of C2H2 reacts with the 50 grams of O2. And we notice that that is less than what we had at the start. We have excess C2H2, which is why it's called the excess reactant. So how much is left? Simple subtraction. Start with what you had, 25 at the start. Whatever reacted with the O2 is gone now, so minus 16.25, and we end up with 8.75 grams of C2H2 is left over, unreacted, excess, etc. And that's the end of a big, long problem. Reminder that this is going to be on Edmodo, so if you need a refresher, go ahead and download it from Edmodo and take a look at it again. Get to work on the homework, and I'll see you next time.